Welcome back, focused learners. You are stepping into the strategist's room for another crucial explainer. Today, we're tackling something that I know, for a fact, keeps thousands of Cambridge AS and A-level IT students awake at night. We are pulling back the curtain on the examiner's blueprint for mastering Topic 7.1 concepts. Specifically, we are going to completely demystify backward chaining, forward chaining, and if-then constructs for Information Technology 9626. Now look, let's set the scene. Picture a real Cambridge computer science or IT past paper. The timer is counting down, the tension in the exam hall is palpable. And I want you to imagine two typical students facing a brutal, multi-part scenario question on these exact concepts. Let's call them Alex and Sam. Now, Alex is a hard worker. When confronted with a chaining question, Alex overloads the answer with every single raw fact they've ever memorized. They dump definitions onto the page, but there's absolutely no analysis. It's just a wall of theory. Then you have Sam. Sam is racing against the clock. Sam rushes through the scenario, entirely missing the specific requirements hidden in the command words, and just throws down a generic if-then statement. What happens to both of them? The examiner's red pen comes out and they bleed marks. It is absolutely heartbreaking because the knowledge is there, but the exam strategy is completely missing. If you've ever felt like Alex or Sam, if you know the theory inside out but just can't seem to get those final marks to reflect your knowledge, you are in the exact right place today. We are going to break this down logically, structurally, and visually so you can walk into your next exam with absolute, undeniable confidence.
So, why are we focusing so heavily on this specific topic today? Look at this. These specific concepts, backward chaining, forward chaining, and those tricky if-then constructs, they account for roughly 15% of your total marks in Paper 2. Let that sink in for a second. 15%. That is a massive, massive chunk of your final grade sitting in just one single subtopic. This isn't just some minor detail in the syllabus that you can afford to skim over on the night before the exam. No way. This is an absolute must-master topic. Think about it strategically. Mastering this 15% can literally be the difference between crossing a critical grade boundary or falling frustratingly short of your university requirements. We are going to make absolutely certain that you capture every single one of those marks. We're going to transform those red marks into green check marks.
All right, let's dive straight into our roadmap for today. First up, we'll cover the core principles. Second, we'll break down the procedural framework. Third, we'll look at critical examiner warnings. And finally, we'll unlock the evaluative edge. Section 1. Foundational Core Principles. Building the base. Okay, let's get into the mechanics. Multi-stage analysis is notoriously difficult, and it requires a rock-solid foundation. I always say, if your foundational base is shaky, the whole analytical house comes tumbling down the second you face a complex, multi-layered scenario. The theoretical architecture of backward chaining, forward chaining, and if-then constructs isn't about guesswork. It draws heavily on established principles of systematic analysis and evidence-based reasoning. It's like being a detective. It is all about following a logical trail. You have to understand fundamentally how one condition triggers another, or how an end goal can trace all the way back to its initial conditions. Let's break it down simply. Think of a standard if-then statement. It is the absolute bedrock of procedural logic. For instance, if the temperature drops below 0, then trigger the heating system. It is precise, it's strictly defined, and it establishes a very clear causal relationship based on verifiable evidence. Now, let's scale that up to chaining. Forward chaining is basically data-driven. You start with your known facts, your evidence, and you push forward through your rules step by step to reach a conclusion. It's like saying, I have these ingredients, what can I cook? Backward chaining, on the other hand, is goal-driven. You start with the final conclusion or diagnosis, and you work backwards to see if the known facts support that goal. I want to bake a cake. Do I have the flour and sugar? Knowing the difference and knowing exactly when to apply each is the very first step in thinking like a Cambridge examiner. Now, here is a massive secret that separates the good students from the truly elite. There is a stark, undeniable contrast between having isolated syllabus knowledge and making active cross-topic connections. The principal examiner reports for IT 9626 are explicitly clear on this point every single year. Candidates who reference cross-topic connections, who integrate these 7.1 concepts with other areas of the syllabus, like database management or network security protocols, achieve significantly higher marks. If you are treating backward or forward chaining in a vacuum as just a neat little logic trick, you are artificially capping your score. Examiners desperately want to see that you understand how these evidence-based reasoning tools apply across the broader, real-world spectrum of information technology. They want to see you pull the threads of the syllabus together.
Section 2. The procedural framework, the method mark strategy. Listen up, because this is the core engine of our entire strategy today. In these advanced IT exams, the final answer isn't the only thing that matters. In fact, sometimes it's not even the most important thing. Examiners actively award marks for your systematic process. We call these method marks. They are looking at the how just as closely as the what. Here is your standardized, systematic, 5-step sequence for tackling any complex 7-1 examination question. This is your blueprint. Step 1. Deconstruct the question. You have to decode the command words. Are they asking you to evaluate, to describe, or to explain? Step 2. Extract the relevant data from the messy scenario they've given you. Filter out the noise. Step 3. Select your analytical framework. Is this a job for backward chaining, forward chaining, or a nested if-then construct? You have to make a choice and own it. Step 4. Execute your analysis with crystal clear notation and logical working. Show your thinking on the page. And finally, Step 5. Verify your results and present them using the exact correct terminology. Following this 5-step sequence ensures that absolutely no method marks are left on the table. It's an incredibly powerful framework. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep moving.
We need to talk about what your paper actually looks like. Because execution isn't just about finding the right logical path, it is completely about presenting your workings in a way that makes it incredibly easy for the examiner to award you those points. You want the examiner to look at your paper and sigh with relief. The source material and the examiners themselves emphasize strict presentation conventions. You must, and I mean must, use proper headings, the correct IT terminology, appropriate formats, and clear, undeniable annotation. Think back to our student Alex from earlier. Alex knew the facts, but just dumped a massive, unformatted paragraph onto the page. The examiner had to hunt for the logic. And when an examiner has to hunt, you are throwing marks away. Make your systematic processing visually obvious. Break it down. Use bullet points if appropriate. Show the flow of the if-then logic clearly, step by step.
Section 3. Critical Examiner Warnings. The top pitfalls.
All right, time for a reality check. We need to look at exactly where students are bleeding marks year after year. Let's look at the red ink. Here are the top 3 mistakes pulled directly from the examiner's own notes. Mistake number 1, answers are simply too vague. Saying forward chaining moves forward is not going to cut it. Examiners don't want broad generalizations. They want specific, targeted details applied to the logic. Mistake number 2, students constantly forget to verify their format and presentation, losing incredibly easy technical marks. And mistake number 3, which is frankly a massive one. Answers are not specific to the context given in the scenario. This is the ultimate trap. If the paper gives you a scenario about an automated medical diagnostic system and you just write out a generic textbook definition of backward chaining without tying it directly to the symptoms and diseases in that specific medical scenario, you will lose the mark. Context is absolutely everything. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's get interactive for a second. I want you to look at this quote. The crucial point of failure is captured perfectly in this direct alert from the principal examiner reports. They wrote, "Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This is a massive red flag from the people grading your papers. This is vital. When you are dealing with complex if-then constructs or trying to explain the subtle differences in chaining methods, you must eliminate any terminology confusion right at the very start of your response. Define your terms precisely before you apply them. It acts as a solid anchor for your evidence-based reasoning. By simply stating forward chaining, which is a data-driven inference method starting with known facts, before applying it to the scenario, you prove to the examiner immediately that you know your stuff. It establishes your authority right out of the gate.
Section 4. The Evaluative Edge. Average versus top scoring.
So we arrive at the million-dollar question. What actually separates an average, middle-of-the-road candidate from an absolute top-tier A-star scorer? It is the mental shift from basic problem-solving to high-level critical analysis. Basic problem-solving, which means identifying the given information, setting up an if-then rule, and following the logical steps, is good. It really is. It will get you the standard marks. But top-scoring candidates go so much further. They demonstrate evaluative thinking. They go way beyond rote application. They look at the scenario, and they question the assumptions made within it. They identify the limitations of the evidence quality, like what if the sensor feeding data into the if-then construct is faulty? They consider alternative interpretations, and most importantly, they justify every single one of their decisions with rock-solid evidence. That critical analysis, that ability to step back and evaluate the very logic you just built, is the absolute hallmark of a top-tier exam paper.
To consistently achieve that level of critical analysis, you need to completely hardwire the deconstruct, solve, evaluate cycle into your brain. This is your ultimate cheat sheet system. First, deconstruct. Identify the given information in the scenario and rip it apart. Next, solve. Break it into logical steps and solve it systematically using your chosen 7.1 framework, whether that's mapping out the backward chaining path or writing out the nested IF statements. But listen to me carefully. Do not stop there. Our rushing student Sam from earlier always stops there. The final, vital step is to evaluate. You must step back, check your results for reasonableness, understand how those results affect the wider system in the scenario, and make fully justified recommendations. Every single conclusion you draw in your exam must be backed by justified, well-reasoned evidence. This three-part cycle is what guarantees you extract every possible mark from the question.
Which brings us to our final thought for this explainer. We've given you the inside look. You have the examiner's blueprint. You now understand the absolute importance of precise definitions, the undeniable necessity of the method mark strategy, the top pitfalls you have to avoid, and that evaluative cycle that separates the good from the great. The theory is laid out right in front of you. So, the only question left is, are you ready to take this precise, systematic blueprint and immediately apply it to deconstruct your next complex past paper problem? Listen, students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams @AceTheExams IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep analyzing, keep evaluating, and I will see you in the next one.